Hello friends, today I would like to talk about the law of electromagnetic induction, which is also called Faraday's law, which discovered this phenomenon. This phenomenon was discovered by accident. Faraday had been putting the magnet into the coil for several years and hadn't noticed anything. The thing is that at the time of Faraday the galvanometer was of impressive size and was located in another room. Therefore, when he returned to take the galvanometer reading, he always found zero. This went on for many years, until one of Faraday's students noticed that the needle moved when the magnet moved in the coil. Approximately so. The most important law by means of which it is possible to receive an electric current was discovered. So let's look at it in more detail. To describe this law in mathematical language, we need such a concept as magnetic flux. Magnetic flux is the product of the magnetic induction vector by the area and by the cosine of the angle between the direction to the normal and the direction of the magnetic flux vector. This is a purely mathematical definition of magnetic flux. The practical significance of the magnetic flux has a slightly different meaning. It's very important to understand that by magnetic flux we mean that number of magnetic field lines per unit area. That is, the more magnetic field lines there are on a given area, the greater the magnetic flux. If we change the number of magnetic field lines per unit area, or the angle changes over time, then the magnetic flux also changes. Faraday established that an EMF occurs in a conducting circuit when the magnetic flux changes. The faster the magnetic flux changes, the more EMF occurs, and this is confirmed experimentally. It remains to be seen what the meaning of the minus sign in Faraday's law is. The minus sign is the Lenz rule, which is a consequence of the law of conservation of energy for electromagnetic phenomena. If you lower the magnet into a closed conducting ring, it will behave like this. If you take the magnet out of the ring, it will look different. What if I put the magnet in an open conducting ring? Will something happen? Write your answer in the comments. So back to the Lenz rule. The induction current by its magnetic field always interferes with the cause by which it was caused. This means that if we want to get electric energy, we need to expend mechanical energy. If instead of a minus sign there is a plus sign, then you will create a perpetual motion machine of the first kind, which creates electrical energy without consuming anything. And this is impossible. I hope you believe in the impossibility of creating a perpetual motion machine. If the magnetic flux increases, we get an EMF of induction which are minus sign. This is the case when the magnet enters the coil. Therefore, the magnetic field of the induction current must prevent the magnet from moving inside the ring. If the magnetic flux decreases, then we remove the magnet from the ring, and then the EMF of induction has a plus sign. In this case, the magnetic field of the induction current prevents the magnetic flux from decreasing. Now it remains to voice the law of electromagnetic induction. The EMF of induction that occurs in a closed conduction circuit is directly proportional to the rate of change of the magnetic flux, taken with the opposite sign. Let's sum it up. Pay attention to how the magnetic flux is determined. The Lenz rule is a consequence of the law of conservation of energy, and the value of the induction EMF depends on the rate of change of the magnetic flux. That's all for today. Until the next projects, bye bye everyone, subscribe to my channel. Sincerely, Yuri Kovalenok.